Okay, we'll make a start on the session. So thanks for joining us on this Thursday. So today we'll be talking about the EHAB Weather Ledger. So it's great to be talking about this project. I have two feelings. I'm happy because it's been a great project. We've got a lot to celebrate and successes to talk about. Also sad at the same time. We've really enjoyed working on the project. So over the last 12 months. Just next slide. So yeah, a welcome from Connected Places Catapult. If you don't know Connected Places Catapult, we're one of 9 catapults. We focus on accelerating connectivity in built environments and transport. And today we're going to be talking about one of the projects we've been working on, supporting SME EHAB and working with a number of partners about the project. So we have a few speakers to join us. Next slide, please. We have Josh Graham, who is the CEO of EHAB, who's we've been working with on the project. We're also really pleased to have with us today Colin Everson, who's Head of Innovation at BAM Nuttall. And also myself, I'll be talking about the work we've been doing on standards to support the project. So next slide. So here's the agenda for the session. So I'm going to be doing a bit of introduction, scene setting about the project before I hand over to Josh to tell you about the platform and what we've been doing. We're then going to be talking about the pilot site. So we've got Colin, who's Head of Innovation at BAM Nuttall. He's going to be talking about the pilot sites where we've been testing the project and some of the lessons learned. I'm going to sort of pick up some of the work we've been doing around standards, and then we're going to have a Q&A session from the audience. So as we go, if you wanted to raise any questions, please use the Q&A button at the bottom of the screen. Just to let everyone know, this is also being broadcast live on YouTube, so if you're not joining us through Zoom, and it will also be available on YouTube to watch for others afterwards. Next slide. So about the project, it's an Innovate UK CR&D funded project. It's led by a consortium. We have eHabitation Limited, who are leading the project. But we're also joined by a lot of expertise. It's different partners from different skills and expertise from across the different sectors. So we've got Clyde & Co, who works with us, who provided legal expertise around the smart contracts. Ourselves, we were working on impact assessments, so to validate kind of the impacts of the project. We also worked with Digital Catapult, who are working on the tech side. On the blockchain and IoT, Ferrovial and BAM Nuttall, who are working on the pilot sites. So it's a real kind of collaboration from a number of different partners on the project. So next slide. So just to introduce what the project's all about. So this is just a bit of context about what is the problem we're dealing with here. So it's a construction innovation project, so it's part of the Transforming Construction Challenge. The focus is around weather, the impacts of weather and construction. So there is an increasing number of extreme weather events that do impact upon construction projects, as this picture nicely illustrates. And one of the challenges is actually, may sound bizarre, but proving that a weather event has actually happened. So having the localized evidence to show that a weather event has happened. UK construction contracts, if you're not familiar, will tend to have a clause within them around weather compensation. So this will be, has a particular weather event occurred within a particular period. So that may be a 1 in 10 year weather event. So in the case of NEC clauses. So one of the challenges is that providing evidence to show that clause has been hit is that it can be a slow an analog process. So lots of paperwork to collect and trying to find sources of data to show that the weather had occurred. And this then causes cost and time lost. One of the disputes is around so there was one example where the site sort of resembled a lake effectively, but the nearest weather sensor was, weather station was too far away and didn't actually reflect it had occurred. So whilst there'd been a 1 in 10 year event, it didn't show that it occurred. Next slide. So what we've been doing as part of the project, we started off with doing some insights. So Digital Catapult, one of our partners, they were working with interviewing different construction staff, so contract managers, site operatives, to understand kind of the challenges they face from this issue. And this is really to help inform the development of the solution. We've also done workshops. So we ran a workshop with the Industry Infrastructure Innovation Partnership, so I3P, to kind of look at these challenges, look at solutions. So output from this, we've the creation of a user insights report to kind of capture these different issues, what are the challenges for construction projects. We've also produced this white paper just to kind of present some of these key challenges and some of the findings. So I'm just going to talk through some of these findings before I then pass on to Josh, who's going to talk about the platform. So next slide. So I think one of the first kind of issues that came up was around negotiating and signing weather terms. The idea is at the beginning of projects, you sit down to agree your contracts with the client and the main contractor. What's kind of came out from this is it's really important that actually at that early stage of the discussion about what the specific risks are posed to the projects around agreeing those contract clauses, and making sure the clauses agreed reflect that, and also thinking about how you're going to manage those weather-related risks through the project. So that was kind of one kind of pain point that came up. Next slide. Another insight that was captured, as we've talked about here, is that around accessing data and assessing impacts. So one of the kind of things we heard was that weather conditions are often viewed as objective. It's either an event has happened or it hasn't. When in fact, when you think about kind of construction activities, the way they're impacted by weather is actually quite different. So this table is just kind of illustrating that. So from doing work on painting to excavating and filling and concrete, they're affected differently by different weather events. So what may not be seen as a weather event in some types of works, maybe in others. So it's not really quite as objective as it may be seen. So it's not purely around a 1 in 10 year event. So some improved kind of clarity around that is important. Also accessing the data is important. So next slide. And on that kind of on that fact, so notification of weather events, so was the fact that there's poor access to reliable, accurate data. So you often don't know if an event has actually occurred or not. So being able to be notified of weather events that have occurred or might occur to help with planning. So that's kind of another insight, is if you had easier access to the weather to allow you to schedule, that could improve kind of the overall weather risk management. Next slide. And the next kind of stage in the process is you then getting estimations and quotes. So you've had you've agreed your weather terms. You've got weather events occurred. You've got the data determined that it meets the threshold. But kind of how do you define that kind of how much is that sort of compensation? And one of the challenges, what is business as usual? So with climate change is always changing, so these thresholds also moving. So the baseline is shifting. So having a fixed kind of level of what threshold should be, there needs to be more kind of consideration of that. Next slide. And final kind of insight was uncertainty around the clause, that compensation claims always can become very argumentative. So the kind of chasing around the paperwork, trying to match the data to show whether it has occurred, that can lead to lots of arguments and lots of delays. So that was another pain point that the project was looking at, how to help resolve that. The typical sort of often 12 weeks, but can be much longer period, and others. Colin and Josh will be able to talk about this a bit more. Next slide. So there were 7 kind of steps or insights around kind of futures, and Josh is going to talk a bit more about kind of what does the future look like. So one is using more localized weather data. That's an important one. Next thing is considering weather risks from the outset. Next is actual better management of weather information, so having that information better to hand. Sharing that weather risk data as well, so having the means of accessing that data and sharing it to different people. Evolving the clauses, so having the ability to have different types of clauses that better suit the circumstances of the project. That was a key kind of next step. Moving towards more of a dynamic threshold, so reflecting the fact that weather risk impacts on different types of works in a different way. And the other kind of insight is around how can insurance, what is the role of insurance? So for example, certain claims, there may be opportunities here for insurance products that could help with addressing some of these issues and managing these risks. So these are some of the insights that were kind of captured and ideas, and then kind of translating what we've actually done in the project. So next slide. So we're going to hand over to Josh next, who's going to be talking about the platform and the projects and what the solution that EHAB have been working on.
Thanks so much, Gavin. Hi everyone. Thanks for taking time out of your afternoon to listen. So yes, the project, the EHAB or the Weather Ledger, it's been an exciting year. So I'll dive right in. Hopefully you can see my screen. So yes, as Gavin mentioned, it's been a consortium of partners who have worked on this project, and I really don't think without any of these, the partners, we would have come up with such an interesting solution. The ultimate aim when we started for us was to try to create the first smart contract solution for the construction industry, and I'm excited to say I think we've done that. But as we've gone through this project, we've uncovered a lot more. So weather is a massive risk in the construction industry, and for some reason it is hard to perhaps understand why, but it's been quite overlooked in the past. So these are just a couple of examples of the type of or the size of the problem. When you consider, construction is a £100 billion market in the UK alone, weather can have a significant impact on cost and as Gavin mentioned, delaying projects. And even here in the UK, weather is becoming more extreme. So the type of changing weather patterns that we are experiencing is more rain in shorter amounts of time. So basically that just means not necessarily more rain overall, but more extreme amounts of rain in a day, for example. And this can then lead to an increased risk of flooding, which since 1990 has increased 20 to 90%. And unfortunately, that's only set to continue. So it's something that's been overlooked in the past, but it's something that we need to start taking a lot more seriously. And I won't dive too much into detail because I know Colin will talk about this later, but we were lucky enough to have 8 different projects across the UK. 5 of those had weather stations on, and the project was done in such a way where we were constantly iterating. So we were, talking with people on site, talking with people in the legal departments. The amount of information that we got has really opened our eyes to just how significant and diverse the problem of weather risk is. So I want to take a step back and really think about, rather than just thinking about the contract, I want to think about what is the contract actually trying to do. It's a tool to manage risk. It's just one of the tools. There are a number of different tools that you can use to manage risk. And what we found through this process was that there's 2 types of risk. So there's the foreseen kind of risk, which is all about, what is the kind of risk that we are definitely going to be exposed to. So, it's no surprise it rains in the UK. So you've got to expect to be dealing with some level of rain in the UK. And on that graph that Gavin showed, even small amounts of rain can impact some kinds of work. So how do we plan to deal with that in a better way? Because, at the moment it's perhaps not dealt with as best as it could be. But then there's the unforeseen side. So what happens when things, go way out of the normal, which unfortunately the climate crisis is perhaps going to increase these kinds of events. So how do we manage and mitigate when, storm, whatever name comes along? How do we deal with those things? So although we started out with the mission to create one tool, we've actually built 4 different tools, which we think can create a much more holistic way of managing weather risk in the industry. So starting at the very start of a project, before any ground is broken, before plans are even being drawn up, you start to make decisions which you don't realize it at the time, but have weather related implications. So, if you're putting a certain task at a certain time of year, that has an implication for how much risk you're taking on. And at the moment, very experienced senior planners make these decisions on a gut feel, which absolutely, has worked in the past, but we think that data beats experience. So, what we get with this enhanced planning tool is we build a baseline, which Gavin was talking about as such an important piece. So we get 40 years of data, and we put this into basically a model where we map not just, we map all of the events, but we weight the most recent years more heavily, because we know that those years, the trends that we're experiencing in those years are more important in terms of that weather baseline. We then project into the future 1,000 different futures. So using that historical weather data as a baseline, we then use advanced Monte Carlo simulations to simulate what 1,000 different futures could look like. And that gives us a distribution of probability of what weather could occur in that particular location. We then load in the tasks that they're going to be that are planned for that year, or for the years that project is going to be running. And at the moment, we have about 650 different tasks in this risk matrix, which is, concrete pouring, steel work, a whole host of different tasks. And we know how weather impacts those tasks. So how is weather going to stop that task, or how is it going to reduce the productivity of that task? And when you then apply these two things together, you can get a really granular understanding of what amount of risk am I taking in my schedule. And so you can start to move that schedule around. You can understand how you should price your contract, and really you can try to optimize your schedule to reduce that weather risk, which at the moment isn't really done. So we're trying to improve foresight. We're trying to lower the risk of weather and ultimately help planners make better decisions. Once the project actually gets going, then the second part of this foreseen weather risk is trying to basically get better information into the hands of everyone on site, because we don't think that weather should be a surprise, right? We've all got an iPhone or an Android in our hands, so we give everyone on site hyperlocal forecasts. During this pilot phase, we did 7 days out, but we're in the process of getting 2 weeks and 6-month forecasts out as well, so that you can be warned with as much time as possible how incoming events might impact your site. And the idea is that this tries to give real-time insights into because there's a lot of different things that you can shuffle around on a site. You can cancel shifts and move tasks around, quite often at least. And this can help reduce some of that cost burden. And Colin may well describe some of the examples later on where we've helped some of the most exposed sites that we were working on. We've also built into it a bit of a connected site diary where people can just put information in a more searchable and structured way to help when if a claim has to be made. And ultimately, it's really around just being proactive. If we can give more people better information, then collectively that can create a more proactive risk management process, and it can streamline it. And obviously, everyone on site is connected to people at HQ, so that information flow is a bit faster. But the smart contracts, so this was the crux of the grant itself, and really what we were trying to do was actually just automate what had already been agreed in the contract. So The first thing to do when setting up a smart contract is to get both parties, so the client and the contractor, to agree to some sort of data source. On 5 of the sites, we use an IoT device, or a micro weather station, if you like, which obviously provides a hyper-local source of weather data. But it could well be some other source of weather data. So it could be data from a satellite, or just data from some sort of aggregated feed. But as long as you both agree that that data set is going to be what you use as the adjudicator of the weather, then that's step 1. That data is then on a daily or every 10-minute basis. That data is pulled into what is called a distributed ledger, which is basically just a database which would be shared between both the client and the contractor, and possibly other parties as well. And the idea with that is that it's completely impossible for either of those parties to tamper with that information. So once the data is pulled in there, that database is secure. So there's no way that you could fudge the numbers, if you like. And sitting within that same database are basically lines of code or smart contracts. And what these lines of code do are, at a very high level, they do what is written in the current NEC contract, which, as Gavin described, I'll give a really simple example. So February is quite a wet month for most parts of England. So a 1 in 10 threshold, which is an event that happens less frequently than 1 in every 10 years, might actually be 25 days of February. Let's just say that 25 days of February would have rain over 5 millimeters. If a compensation event were to occur, 25 days would have to measure over 5 mil of rain. And so each day that is measured over 5 mil of rain, that information would be coming into the database. The smart contract code would be checking. It would be saying, is this over 5 mil? Yes, it is. Add another day to the month of February. If it gets to 24 days and then there are no more days, and it's the end of the month, then that isn't a compensation event. If it breaches that threshold and goes to 26 days, then the system notifies everyone. And not only does it notify everyone, both the client and the contractor automatically accept that that is a compensation event. So at the moment where they may take months to wait for data to come back from the Met Office and have a discussion and sort of have to prove the fact that this event has occurred, this literally is instantaneous. So it's all about trying to improve the efficiency of that contract management. And we hope as well have a lot of knock-on effects in terms of reducing disputes as well. So it's trying to create a shared understanding of what the weather is on a site, but also have instant decisions being made. So trying to lower that risk of human interference. And there's actually I'm not going to mention it now, but potentially later on some really interesting implications for what are the next steps of these smart contracts. But really briefly, so using that same smart contract technology, we've also produced a parametric insurance product, which is using that same fundamental principle of people agreeing to some data in a database, and that database triggering some sort of action. In this case, it's a smart policy rather than a smart contract, and it's basically making a payout. So an example could be if it's so windy that a crane cannot operate, and that crane is really, really vital to the critical path of a project, it's called. And the company knows that it's going to cost them £100,000 to rent the crane for an additional amount of time. Well, then if that wind goes above that certain threshold, the insurance company would pay that money out automatically. That's just a very simple example, but you can start to think of quite a lot of intricate ways that this payout could occur. And the idea really is that the insurer and the contractor have a shared understanding of the information that is contributing to that event, i.e., the wind data and the fact that it's impacting a crane, and ultimately that helps cap the project's risk. because in an increasingly volatile climate, you can imagine these kinds of, maybe not wind, but rain events are going to become more frequent. And so there's this level of protection that you might want to put in so that you don't have ballooning costs from these more extreme events. And the benefit of the parametric is that there is no claims process. If the contract and the smart contract in the data says that the weather has hit whatever threshold you chose, then the payout is instantaneous again. So it's trying to speed up some of the things that traditionally take a lot of time, effort, and energy. Yes. So my final, sorry if I'm waffling on, my final sort of piece to this is we are really excited by this concept of rewriting how the contract actually deals with weather risk. So I've called it a dynamic data-driven risk sharing model. But in simple terms, what we have built in terms of the model is we can model what the actual risk of a site is with our Monte Carlo simulation, and the client, the contractor, and possibly the insurer could all sort of say, we're willing to take this amount of risk. So they can put a line in the sand, if you like. And this really basic illustration should sort of show you what that could kind of look like. So, the contractor takes a significant amount of the risk. So whenever, temperature is up to a certain level, we are the ones who pay for that kind of risk. The client may then take some other element of risk, and then the insurer might take the most extreme amount of risk. But what we're keen to try to explore is that that risk sharing distribution is effectively could be calculated by a system, and a number of options could be presented to the human commercial negotiators, and they could then sort of select that on a screen, and that then becomes the level of risk that they're willing to take in their contract, and especially if they're willing to share the costs at certain weeks into that model as well, then the system could not only automatically say that a compensation event has occurred, but it could automatically make a payout based on a time, based on where that impact has actually happened in the program. But unfortunately, I think that's probably a little bit down the line, but certainly the technology exists to make that happen. It's probably just going to be, chipping away at improving that over time. So thanks so much for listening. That's my part of the talk over, but please, if you want to reach out to me, the email's on screen there. So please do that. Thank you.
Thank you very much, Josh. That was great. Yeah, really great sort of insight to explain kind of what you're doing with the platform. As you can see, it's quite innovative ideas, quite transformational in terms of thinking about rethinking about how kind of risk is managed. Now I'm going to hand over to Colin, who's going to talk about some of the pilot sites and some of the lessons learned. So over to you, Colin.
Cheers. Thanks a lot, Gavin. Could we have the next slide, please? Yeah, firstly, I just want to say that it's been a really enjoyable 12 months. Quite a bizarre 12 months because we've had to deliver this project in an online way, if you like. We've not been able to have any of those sort of workshops in the room together. We've not been able to go on site visits together like we originally planned. So it's been quite bizarre from that respect. But there's been a really good team, and I have to admire the energy and the enthusiasm of someone like Josh that's seen an opportunity like this with industry, and he's been determined to come up with a solution in order to improve our own industry. So we really just welcome people like Josh and his colleagues at EHAB to, I guess, challenge what we do now and maybe get us to think a little bit differently. Next slide, please. So really, I just thought we'd just spend a moment reflecting on why we innovate as a business. So BAM Nuttall is a civil engineering contractor, part of the Royal BAM Group. We deliver all sorts of infrastructure projects, mainly throughout the UK, but some international projects as well. And one of the reasons that we dedicate a lot of time and effort to innovation is that as a business we can't stand still. So we've got to be constantly seeking improvements in what we do and how we deliver those projects. We need to challenge ourselves and not sort of rest on our laurels on the last project was great, but we need to start thinking about the next project and how we can deliver it in an even better way. Obviously, it's also good to be seen to be innovative by our clients. There's a constant drive for us to evolve where we have repeat business with our customers. And it's also, I think, really the public probably demand it as well. Most of the projects that we deliver in UK infrastructure are effectively government and taxpayer funded projects ultimately. So, as being a member of the construction industry, we've got we should constantly improve the way we deliver value for the UK public. Next slide, please. So just to put this project in a little bit of context with some of the other innovation projects we've got in our portfolio, and there's I guess they're all distinct in their own rights, but there's some areas of overlap. So the topic of IoT devices is very current at the moment, and we're working with people like Eve on active hearing protection devices. So that's a wearable device. And we're also delivering a 5G project that actually, in the future, a 5G network will enable many hundreds of devices to be able to be deployed on a construction site. So what the Weather Ledger has done is actually is give us some real insight in the feasibility and the practicalities, and also some of the challenges of deploying an IoT device in a construction site. It's from anything from the connectivity to the power supply, even just how to suitably deploy it when it's a bit out of the ordinary from what our project people are used to deploying those kind of devices. So we're also grateful for those projects and giving up some time in order to enable us to deliver these projects. Next slide. So when we were starting out at the beginning of the project, we were discussing with Josh what kind of projects do we want to engage with, and these are just the BAM Nuttall projects. Our colleagues in the consortium of Ferrovial have been engaging with some of the HS2 enabling works projects further up in the Midlands that we've been working on. So we've got a fairly good sort of representation of the type of projects that we deliver within BAM. We started off with Houghton Brook, which is just on the outskirts of Luton, next to the M1. So this is a flood protection scheme for the Environment Agency. It involves quite a lot of earthworks on the project. It's weather sensitive because it is in a flood area, and the idea is that the project builds a flood bund to protect some future development. So again, that's a good test of the weather impact on earthworks projects. Then we've got a project we're delivering for London Underground, so it's a much more urban environment. We're delivering a step-free access project, so it's a completely different type of project at an underground station in an urban area in north of London. Then down on the south coast, we're back into more of an earthworks kind of project of Hampshire County Council. And then finally down on the southwest, we've got Dawlish. Next slide, please. So this project here, Harrow on the Hill. So I've taken this a bit of a screenshot from Google Earth, and hopefully it demonstrates, I guess, some of the geometry of the urban environment that can affect the weather. So when we were talking to the team there, they were saying one of the problems that they're faced with is the local wind effects that are caused by those high buildings on the right hand side. So there's on the left hand side, we've got sort of 4-story kind of residential buildings, and then the site office and compound is where that pin is on the map. But then you've got these sort of residential blocks that go up sort of 12, 15 stories on the other side. So you get some very strong local wind effects that are not actually reflected in the defined weather station that's defined in the contract. So there it's important to actually measure the local wind effects, because that has a direct impact on how some of the crane operations are able to be undertaken, for example. So, you know, there's elements of nighttime working when the railway is closed, and we're lifting large elements over the railway to provide the overbridge for the step-free access. So when you think about how weather's dealt within the contract, there's a defined weather station, and it could be several miles from the project. And usually these weather stations are in a sort of an open, flat area that are not disturbed by, you know, sort of buildings and obstacles like that, just to get, you know, a true reflection of the weather. But obviously then what we're not doing is measuring the impact of the weather on the construction site. So we've been able to get some good insights into the measuring the wind direction and the wind speed there at Harrow on the Hill. Next slide, please. So this is down on the south coast in Hampshire. So it's a location of a bypass that we're currently building for Hampshire County Council. So much more of a rural environment, still very much focused on earthworks. I was speaking to one of the colleagues from the project earlier today, and you know, they've really struggled this winter with the amount of rainfall that we've had, and actually the ground conditions, it's just holding the water. So that's it's had a real disruption to some of the earthworks that they've been having there over the last few months. And we've got a couple of weather stations there. So the client asked us to install a weather station at the start of the project, and then subsequently we approached the project, so we've got a weather station that's associated with a weather ledger, and we've had some good anecdotes from there. I think it's fair to say with all the people that we've engaged with across the whole project, everyone has got a story of how weather has impacted either their current project or one of the projects they've been involved in previously. And just touching on the range of people there that we've engaged with, from site engineers, commercial managers, estimators and planners at pre-construction stage. We've had a huge group of people that have given us time to engage with on the project. So yeah, that's another one of the projects there. Next slide, please. So this is Houghton Brook. So as I said, fairly similar to the kind of works at Stubbington. It's an earthworks project. This is it's quite an early view taken from Google Earth before the project started. It's in its last few weeks there now, really, that they've managed to keep going throughout the winter, building their bund. I think maybe this has been slightly less affected by the weather because they're importing material from a clay pit and then built in the bund on site there. So they're not having to rehandle the material too much on site. So, but they've had weather events, as with many projects. Back in, I think it was late summer last year, there was some extreme storm showers that they recorded on site there, which disrupted the site in the sort of the next few days following the event. So we've been having some really good measurements from the weather station there, and that was one of the first projects that we deployed on. And again, it's always a bit of a black art of how do you actually pick the right project to engage with. And I guess the team at Houghton Brook, we just know them as being quite open and forward thinking, and they're willing to give them the space to try some of this stuff. So, huge thanks to the people on the project. Next slide, please. So this is the final site that we've deployed on as part of the project. And as you can see, this is probably at the more extreme end of the weather events that we've had there. So this is down on the south coast of Devon at Dawlish, where the mainline railway that links essentially London down to the southwest of England runs right along the coast there. Back in 2016, there was a massive area that was actually washed away, and there's a temporary measure to install it. And then this is a scene from I guess last autumn. I think it was the end of the autumn. Some of the storms that they're faced with, and the way the coast is aligned, you get in the full reach of the Atlantic coming hitting on that part of the coast. So we've got some of the construction plant that's planted parked up safely in the right-hand side of the picture. The waves in the middle there, you can see that they've been arrested, if you like. They're sort of turning back on themselves because the wave wall is installed. And at the bottom, this is the problem that railway was facing many times during the storms, is that the sea wall is not high enough and it's not the right shape to deflect the sea back onto itself. So there's massive disruption to the railway there. So yeah, slightly different scope of work. It's not really an earthworks project. This is more about marine working. So we're working around the clock, 24 hours a day, but we're working in different shift patterns to suit the tide. And again, you know, the site team have been very helpful in giving some insights in how they manage the project and how they manage weather currently. And we hope that in the following years, when we're delivering the next phases of those projects down at Dawlish, they can start to get some, I guess, make better informed decisions when they're putting their programs together and when it comes to short-term planning of those activities. And then now we've just got a short video which it just shows some of the specialist construction equipment that we deploy on some of our projects. This one is called a wave walker. It's used as a mobile platform to install some of the steel piles that are needed for that project. And I guess you get different types of equipment are affected by weather in different ways. You know, we've had craneage that's been affected by wind at Harrow on the Hill. We've had earthworks excavators affected by rainfall at Stubbington and Houghton. And then down at Dawlish, the wave walker and the crane that's attached to it has been impacted by wind mainly, and also to the sea conditions. And there was a delay when it came to actually demobilising that piece of equipment at the start of this year, just because of the storm conditions. So if we have the next slide, we can get a bit of an idea of the type of work that's been going on there and the equipment that's being used. Next slide, please. So finally, yeah, just thanks again to Josh for inviting us to be part of the consortium on the Weather Ledger. We're really pleased that we were successful in winning the funding from Innovate UK, and also thanks to the many dozens of colleagues that we've engaged with across the BAM Nuttall business to draw out some of their experience and insights in dealing with weather, and then hoping to develop a tool that's going to benefit the industry in the future. Thanks very much.
Great, thank you, Colin. Really fascinating to see, really tangible to see, I think. So, particularly the scenes at Dawlish Warren. You know, if there's anything that kind of represents a project, you know, that picture of the seafront at Dawlish Warren and the wave walker, amazing. Seeing that I imagine being there on the beachfront, you know, with the kids, seeing that kind of arriving might be a bit daunting, but fascinating kind of seeing some of the different kind of equipment, technologies and how they're impacted. So yeah, really great. So just kind of final sort of section we're going to kind of cover now. I'm just going to tell you a bit about some of the work we've been doing around standards. So the project's been dealing with two technologies that are kind of, it's also a bit of a first really in terms of using distributed ledger, Internet of Things. What are they? How do they work? Can we kind of trust that they work? And so I think a lot of the work we've been doing with regards to standards was just looking at kind of standards related needs. So how do we make sure that the way technology is used is aligned with best practice? But actually, given that these were, you know, this new technology, a lot of our focus of our work has been how can we support others to deploy these solutions in other construction projects? How can we kind of help scale their use elsewhere? So yeah, this is a bit about why kind of standards are important. So yeah, kind of giving confidence in these new technologies really, so that others can kind of deploy them at other times. So next slide. Yeah, so the work we've been doing, so we've when I work on standards, we've identified kind of 5 key sort of issues. We came together in a workshop thinking about the technology, thinking about, you know, what are the key issues. So the actual standard weather clauses was one of the issues that came up. So could we redefine that? And Josh talked about this new dynamic risk approach. So that was one of the ideas that came from that session. So we kind of did a lot of work thinking about that standard weather clause. Another key area is, you know, we're using smart contracts. Kind of how do we govern them? How do we kind of manage those contracts? Another is how do you actually deploy IoT? What's the best way of doing that? How do we ensure it's kind of successful? You know, Colin was talking about you know, putting weather sensors on construction sites. You know, weather sensors often used to being in a very kind of open area, specific types of locations. How do you do that in a construction setting? Also touched on some of the kind of issues around, more technical issues, I guess, around interoperability, information exchange. Next slide. The key priorities that we focused on from the projects, so we all kind of agreed what's the focus. So the first was this around the 1 in 10 year event. So we did a workshop around those kind of challenges, and we produced a white paper around that particular topic. We've also, second part of it is around, so we're using smart contracts. So one of the solutions that's being used is smart contracts. So the thing we've done is looking to align with what is the emerging kind of standards. So there's a new BSI standard called PAS, which stands for a publicly available specification. 333 is the number. And this specifies like provides a specification for smart legal contracts. It was published in April last year, so just when we started the project. So it was good timing in some senses. So as part of the project, we're able to feedback to BSI with our feedback, and we've been sort of testing it out through the project. So drawing on some of the practices that are defined in there. Another key output we've worked on is you know, the fact is we were lucky to have kind of 5 sites for us to see how it goes. You know, how do you deploy IoT? What, you know, if someone tomorrow would say, okay, where do I start? What would we tell them? What would we explain to them? Oh, make sure you don't do this, or make sure you do think of this. So what we did is we kind of captured a lot of lessons that we learned about setting up micro weather stations, and we put it together in a sort of how-to guide. So next sort of few slides, I'm just going to talk you through really to sort of present some of the lessons of using IoT and what we've translated into this guide. So next slide. So this is this is a setup at Houghton Brook. So one of the kind of challenges you're thinking of with deploying kind of ITs is, well, you need power. So here we have showing the gateway. At the top of the pole is the IoT sensor. you need a reliable power. With construction sites, they often won't have power. So here you can see we've had to come up with an off-grid. So off-grid setup. So digital catapult was specified this. One of the things is we learned from this is that whilst the manufacturer of the PV panel sort of guaranteed a certain level of output, we found that actually British summer doesn't really kind of provide you enough. So one of the kind of lessons that was learned was that there was some kind of outages as a result of kind of that power loss. So what we've reflected now is that you need to kind of size that much larger. And the other thing that we did working with EHAB is looking at actually having backup. So one of the things that EHAB were just as part of their system is also using other sources of data. But this is just kind of learning that, making sure that you kind of size it. So assume that you're only going to get 1 hour's worth of power from the sun to supply your devices. So that's kind of one of the kind of learnings there, was about sizing the system. So this is a pilot project. So it's obviously we had certain kind of budgets with the kit. So but it's important to kind of present these lessons, what you learnt, and we're able to kind of apply that to other sites as well. Next slide. So the kind of output we've produced. So the work we've done in this guide really is all of the kind of goods, the how we solve lots of these problems in terms of using IoT on a construction project. So we developed a set of deployment criteria, effectively. So if you were going to deploy IoT, we described what you should do at each stage. So you're planning a project, what do I need to think of? That's effectively, so something that's really practical. One of the difficulties we find with lots of standards is they're like really highly technical. So unless you're really technical, they can be hard to use. And what we wanted to provide is something that's quite hands-on and practical that people could pick up and go, oh, that's really helpful. That's helped me know what to do. So that's been a real focus for us on this guide. Next slide. So firstly, kind of what we've done is try to define what do we actually mean by effective IoT deployment. So firstly, we came up with a definition. So next slide. So how we've defined this is really thinking about, well, on a construction site, you want to kind of minimize any particular disruption, and you may not be able to get to site easily, especially the last 12 months. So obviously COVID-19, many of us didn't go to sites because of travel restrictions. That way, obviously, doesn't mean that's always the future. We hope. It's not always easy to get onto sites, so you want to ensure it's easy to install, trouble-free, it's reliable, secure, trustworthy, and resilient. So the kind of key areas. The other kind of things that we defined here is it needs to securely collect and sends the data, supported by robust contingency measures. So not having any single points of failure. Also having backup plans, so not having just one sensor, so having more than one sensor, so you can back that data up. Next slide. So what we've defined is 5 principles, effectively, so to guide kind of IoT deployments. So the first one is around good data management. We've got robust testing and performance. That's a key one. So having kind of devices you're selecting that you've got kind of verified performance of them. Self-sufficient, so self-sufficiency and being kind of simple. Proactive maintenance, and then finally security and resilience. Next slide. So around good data management, kind of what we mean by this is kind of having a reliability. So what you don't want to do is specify a much higher level of data than you need. So every time a device sends information, it's using power, it's using connectivity, all that data needs to be stored and processed. So you only need to provide, the first thing is defining what actual information do you need from the start. So kind of that's a key one. Also think about how critical is that data. So if you've got a really kind of critical data set that you're going to be collecting from the devices, then you may need to kind of specify more kind of robust security provisions, for example, or the level of accuracy that the devices have. So you might want to specify devices that have done field testing, for example. Also having backup processes and procedures in place. So like with the actual projects we did, we used backup sources of data. So not just kind of from the sensors themselves, but using other backup sources. Next slide. So the next kind of theme is around testing performance. So having devices that satisfy. So if you're looking for devices that have 95% accuracy, then obviously it's looking for evidence of that, so that they've been tested. So that might be field testing. So it might be whether devices have been tested in the field and they've got evidence to kind of support that. Next slide. The other thing around, next principle is around self-sufficiency and simplicity. The other thing here is being able to deploy without reliance on technical people. So something that can be out of the box, requires a site visit, doesn't require a site visit, very much a plug and play type system that's can be kind of easy to use. One of the kind of challenges we envisage from IoT is there's so many different applications. You can end up with almost 50 different kind of devices all around the site, which could be really complex to manage. So something that's really simple, self-contained, plug and play is really important to manage those kind of particular challenges. The other thing is devices that are kind of self-contained. They can store data. They're self-powered. Yeah, so they're the kind of other key challenges. Next slide. So the next principle is around kind of dynamic maintenance. So a device that's able to report health data. So raise alarm if its battery life is getting too low. I mean, ideally, you should be specifying kind of devices that have battery levels that are going to kind of support the length of the project, but also able to store data as well. So if there is a kind of a connectivity outage, the data is still being stored by the device itself. Next slide. And then the final principle is around security and resilience. This one is very much, as we talked about the level of data requirements, is around the criticality of the project and what is the data you're actually processing. So specifying a level of security that's appropriate to that particular site. So a security-minded approach is the key thing here. This is kind of a principle that's being applied in construction, the security-minded approach that's coming out of a lot of some of the international standards. So assessing the specific risk factors that impact on the site and the level of security that you need to adopt. One example is around updates. So for example, it should be simple to update a device. So if you need a new patch, so a new software update, that should be supported and without any major disruption as well. Next slide. Now, in terms of applying these principles, what we've done is then devise kind of 5 stages. So going from planning stage, so planning a project, through to procurement of devices, the deployment, operation, and then through to recovery. So next slide. So the planning phase, this is thinking about where you're gonna locate your devices, what actually information you're going to collect. So having a deployment strategy, marking out on plans so that everybody knows where it's going to be, thinking about where it's not going to be disrupted by site works, thinking about what power is there, what connectivity, what the cyber-related kind of issues on site. Next slide. Procurement phase, this is very much helping around what actual kit do you need? What do I need to buy? So thinking about the types of sensors, what sort of requirements do you need to specify? What sort of accuracy do we need to think of? Do we need to sort of verify their performance, how they store the data, what their power supply is? Another kind of thing that we kind of raise is that not just thinking about the construction stage. So many of these IoT devices, you may use them through the life of the building or the life of the infrastructure project. So talking to the client about how they might find it useful to maintain that device further down in the life of the project. There's many different sort of devices, not just kind of weather sensors, but it could be something that signals a door's opened, something like that, to show that, or something's fallen over. So, for example, I mean, obviously the worst case of it in a crane, or something else around kind of, you can use them for some curing of cement. So there's many different kinds of devices that could be used. So thinking about other uses it might have throughout the life, and installing it in a location where it may be more permanent. Next slide. Deployment is a kind of next kind of stage. So that's thinking about siting and positioning. So locating the device, in a suitable location. So, away from kind of anything that's going to tamper or interfere with its functionality. So wind sensors, wind devices, so need to be at a certain height. So that's, we've kind of defined that as well. Also kind of calibration as well, getting kind of calibration certificates, and certain sites you might need to locate them in a more kind of secure location as well. Next slide. Operation, this is really thinking about any maintenance. So having someone that's able to monitor any alerts that kind of come up during the process, and monitoring that the data looks how it should be, that there's not kind of discrepancies that you might expect. And final slide about the guide. Final stage is about recovery. So at the end of a project, so if you're not going to maintain its use during its life, then you need to think about demounting it, sending it back to the manufacturer possibly, or reusing it on another project, and also recovering any data that the device may hold. So that's kind of a final area to think about. Next slide. So kind of next steps really from this guide is we're saying that we've captured kind of lots of learnings about IoT deployment. We want to kind of continue learning, so we're really keen to hear from others that want to look to deploy IoT in construction. Really keen for others to use this guide. If you're looking at deploying IoT, let us know how useful you find it, if there's anything that can be improved. And also, yeah, it's part of supporting the project, having a bit of legacy, so helping others to implement kind of weather devices or other IoT applications. So yeah, do get in touch if that's of interest. Next slide. So yeah, so that's kind of a wrap now. So we've kind of finished the main presentations well on time. So we have some time for questions. So let me have a look at the Q&A. So kind of first questions. So interesting kind of question here. I think one for you, Josh. So one question that's come up is, what about deploying, so this is around different regions. So what about deploying solutions on construction projects in some of the new and emerging cities in the Middle East? I think I was reading about this the other day, this 125-mile long city they're building in Saudi Arabia. It's going to be one of the hottest locations. You hear lots about heat impacts on construction workers. What are your thoughts about kind of deploying for some of these other kind of use cases around challenging environments such as that?
Yeah, great question. And I think the answer is yes, we can. Is a simple answer, but I guess the good thing about weather data is that it's available globally. So there's no shortage of weather data out there. So the applicability of the solution really just depends on where do you want it deployed. And I guess just as a sort of an additional add to that, I think from when we started speaking with people on sites, we were talking about hotter temperatures affecting work. A lot of the time they said, oh, well, that's not something that has really impacted us until the last couple of years, when there were some examples where hotter weather had some implications for sites. So I think, although certainly in the Middle East, clearly that's a massive issue, in the UK, in Latin America, and lots of different places where droughts and hot weather will become more frequent in the summer. It's an impact that perhaps those locations haven't had to deal with before and may start to face that reality in the future. So I think, yeah, I don't know if that, hopefully that answers that piece.
Yeah, I think one thing that's interesting is around, so I guess one thing about the question is around sort of some of these like health and safety issues as well. So Colin, do you think, how does this kind of have benefit in terms of from a health and safety impact as well? So that's a real focus of so many construction projects is, any thoughts on that?
Yeah, well, I think although sort of, these Middle Eastern projects have extreme weather in terms of high temperatures, I guess because of the seasonality of the weather in the UK, we might plan for, a sort of fairly average year, but we might have activities that shift in the program. So if they move from one season to another, that's one of the areas we explored where, you might be trying to do, say, earthworks instead of in the summer. Maybe there's some program slippage and you end up doing it in the winter. So, there's different things to, take into account, such as productivity rates. So the productivity changes, and also the working environment. So if it's going to be more wet underfoot, you might have more slippery conditions. You might have to spend more effort on some of the access routes on the project. So I think, what it does is, it gets us to think about the wider aspect of the weather impact. So when things change from what's planned, so quite often we're planning these projects. It could be 1, 2, 3, several years in advance of when the work actually takes place, depending on how long it takes to procure the project and how long it takes to deliver the project. So I think it just raises the profile of about how weather impacts the projects. And also in the discussions we've been having, we've been identifying how different operations are impacted. And we've created a huge table. Josh has created a huge database now of different constraints and how they're affected by different types of weather. So whether it's operations of cranes, whether it's the handling of different types of materials, and if we handle it in different types of weather, there's obviously different safety considerations to be dealt with there as well.
Just another quick point, actually. One experiment that we would want to run if we were being invited onto a project in the Middle East is to think about what if you were to, because at the moment, the way that we run our model is like an 8 a.m. to an 8 p.m. kind of day. Well, what if you changed that? What if you made it so that it was all night shifts? Clearly, the potential implications of the weather would be very different, especially if temperature is your biggest risk factor. So what you could do is create, what if scenarios. Well, what would be the change in our productivity and the change in our costs if we decided to just not work in the day or to work not in the middle of the day when we're most exposed? So maybe you could actually, shorten the entire schedule. Maybe it would increase the cost because you've got to pay people more in the evening, but maybe that trade-off is valuable, and this tool can help you see that and understand that and model that a little bit better.
Very good. Yeah, no, it's really interesting. Just looking at some other questions that come up. So yeah, one of them was, so how receptive were staff to using the technologies? Did you need to do much to kind of onboard people? Was that kind of pretty simple?
Yeah, I think in general they were pretty good. I think a little bit is that we we subconsciously maybe rank people on their receptiveness to some of this stuff. But I think, it's fair to say that everyone that we reached out to on the projects was very receptive. We were very conscious that they've got a project to deliver, they've got a scope and a program and a budget, and it's a signed contract in place. So it's very much about, if you can give us some of your time, we can make your current job a bit easier, or maybe your next project a little bit easier. So I think it's the soft skills of persuading some colleagues to help us out certainly come into play. But no, in general, I think maybe it's because the project is very relevant in terms of when you start talking to people. They all, they can all strike a chord with it. Everyone has got, as I say, a story to tell about how they've, come across weather impacts in the past. So maybe that's part of it, that, once you start talking to them about that topic, they're very open to collaborate.
It does always seem to be people's favourite topic, the weather. So absolutely, so that kind of gives something common to talk about. So I think that's what the thing about the project. Everyone's kind of got behind this kind of problem, this idea, and this kind of challenge, and that's what's been enjoying for me from my perspective. Absolutely. Another question that's come up is around kind of, if we could do something differently over the last 12 months amidst the pandemic, what would it be? I mean, reflecting that myself, I guess it's been challenged kind of engaging with as many people as we normally would. So as part of the project, I don't know if you both got any reflections on that.
Yeah, I mean, one of the comments that I made there is that I guess we're always think we could engage with a wider audience, and it has been a challenge over the last year because it's all been, online events. So I think, within the constraints, I think we've done pretty well. In a more normal time, if you remember what those were, I think a lot more face time, just visiting sites and talking to different people face to face, and also exposing, people from outside the construction industry, people from the catapults and Josh, just to get them immersed in some of those different construction environments, just to sort of soak up, the environment and challenges that people contend with, really. But I think we did very well considering the travel restrictions that we had.
Absolutely. Final couple of questions. So I know you've kind of answered some of these live. I think it's just good to kind of have a bit of a discussion around as well. So one was around if you could digitize other parts of construction contracts, what would you choose? Or is that viable? Are there kind of other areas of contracts that have similar challenges?
Sorry, Colin, to jump in. I've got a view on this that technically it's 100% possible, but it requires quite a lot of, and I've sort of answered it in the text there, but it requires a lot of data sharing to enable things like that to happen. And in the scenario of weather, it's obviously it's a third party is providing that data. So, it's not Colin and BAM or their client giving information. Whereas in other parts of the contract, it would require both sides to provide information that they perhaps are the author of. And so inherently you have in that scenario, not to say that anyone does this, but there's the potential for that information to not necessarily reflect the exact truth. So it's, as more digital systems become used in construction industry, which, as Colin mentioned, he's got loads of other projects going on, and it will happen. That data will eventually be there, but I just don't think it's there right now. And obviously with weather, I can go to a number of different sources and get really, really accurate, fantastic data. Whereas I couldn't say the same for, ground sources or other kinds of things. So I think from our point of view, it's about data availability.
Yeah, and I think I guess maybe it's some of the problems that digitization has brought us in recent years. So when I sort of started out in construction, when you were issued tender documents for a project, it would be, a couple of ring binders full of paper documents. Then we moved to, say, the client would issue you with a compact disc with all the information on. And then over the last few years, I went to one startup meeting with one major infrastructure client, and they said, well, at the break in the briefing, can you come and collect your hard drive? So you end up with, I think it was 60 gigabytes of information that you need to digest and then provide your price and program for delivering a project. So I think, if we could maybe come up with some smarter ways in sorting through and sifting some of that information and just bringing the important stuff to the surface, I think that would be welcomed by quite a lot of people.
Right, yeah. So that's good. And then in terms of what would you say you've learned most from the projects? I've learned lots about weather data, and what would you say you've been your biggest learnings? I
think some of the conversations that we've had, it just sort of challenge people to reflect on what they do now, and I think just some of the discussions when they just verbalise, oh, this is our approach and this is how we do it. It just, we've sort of challenged ourselves as a business, saying, well, is there a better way? Could we be more consistent? Could we be more uniform in our approach? And I think, we've done some good work, certainly in the last couple of months, of trying to integrate, the risk assessment of the Weather Ledger, and then the P6 tool that we use for the contract program. So, it's all very well sort of exploring new tools like the Weather Ledger, but we need to try and integrate those into people's daily tasks. And so I think, that's what we've learned really. It's just a bit of sort of self-questioning, I guess, in some of the approaches that we've developed over the years.
Great. And Josh, one for you is kind of, where's next? I mean, kind of where's next for Weather Ledger? Have you got, it might be something that people are curious about. How things going?
Yeah, I think, as Colin and you've both said, it's been a pretty transformative and really fantastic to be part of it. And I think for us, we're just going to keep developing, keep hopefully speaking to, a number of the people we've been speaking to through this project and the relationships that we've built, keep learning, because, as Colin said, there's so much to uncover there and keep finding out. But I think the good, the best thing is obviously there's loads of documents and outputs that we've produced, but there's also technology that's ready to go. It's still got a ways to go before that completely automated future I was describing and that we sort of have come up with. But I think, the first steps of an automated contract and, better risk management tools are there. And so, I don't know what to say. We're probably going to keep working with everyone in this consortium, I hope, and keep, delivering talks and just keep developing it really.
I absolutely agree. It's been fascinating in terms of uncovering some of the different layers, just from some of the different conversations with people and different components to this. And I think having this conversation, whether it's so topical always, having this conversation about how to, improve this practice, testing out this technology, having some live sites. It's been a fantastic project to work on. So thank you guys. It's been good to work with you. Not being too corny here, but it's been a great project to work on. Just to wrap up the webinar, completed slightly early, but that's all good. Just going to wrap up and talk about. So thank you to everyone for joining. Thank you to Josh and Colin for your talks. But just to talk about some events, what's coming up next, we've got some further webinars coming up at the Catapult. So we have a final show and tell from our VeriCav project. So this is looking at verification of connected and autonomous vehicles. We have our, that's on the 22nd of March. If you want to go to next slide, we can talk through some of these. So VeriCav final show and tell. Our next event kind of following that, we have something called TRIG, showcase webinar. So that's the Technology Research and Innovation Grants Program, funded by the Department of Transport's Future Aviation Security Solutions team. That's coming up on the 23rd. Next slide. We have also got breakfast briefing coming up, enabling thriving urban communities through sound sensing AI technology. So that's going to be a really interesting one coming up on the 24th of March. If you're interested in kind of the smart city space. Connected to what we've been talking about, so HS2, we've got an accelerator program demo day coming up. So accelerator program that we're working on with HS2. Do join us for that on 25th of March. Next slide. We also have the huge amount of press around kind of drones and their been used in COVID, from delivering vaccines to many other areas. We've got the government's Drone Pathfinder community webinar coming up on the 31st of March from 10 till 1. That's set to be a really interesting session, so to hear about that. And next slide. And another one around kind of more focused on